can see me. Hello, Internet. Hello, people. The talk today is about fast UIs for many devices, cross-device fast UIs. So first, I guess I should introduce myself. My name is Boris. I work for Chrome Developer Relations. I'm an engineer there. Mostly, I focus on Chrome for Android these days. So my interest is in mobile broadly, not just Chrome for Android. So we'll be talking about that, and I'll be demoing some things in Chrome for Android. I'm going to try to make this as interactive as possible. So if you guys have questions, interrupt me. If there's too many questions, I will interrupt you. So how's that? Cool. All right. So there's two parts to this talk. The first part will be about cross-device bit. So we'll talk about what that means, how to do that well, how to do that not well. And then we'll talk about fast UIs for a lot of touch devices and other types of devices. So firstly, why do we even care about mobile? I'd like to motivate this a little bit and also question some of these terms. But anyway, you've probably seen this graph already. Pretty much every mobile web speaker is like, hey, look, I'll be using mobile web devices very soon. And actually, interestingly enough, there's a trend pretty much consistently across the board where people use mobile devices a lot more than desktops during weekends and during holidays. So actually, the first time there was a crossover, according to some Google stats, was in December of 2011. So combined with holidays and weekends, we actually saw more mobile usage than desktop usage in a lot of properties. But, whoa, sorry.
Actually, let's do that.
Yeah?
Yeah.
Whoa. OK, cool. Sorry. I'll try to do that and still look at my slides from time to time. So the thing is, mobile is really a weird term. It doesn't really mean that much, as far as I can tell. Like, does it include phones? Probably. Does it include tablets? Maybe. Does it include TVs? Probably not. Cars? Anyway, and what's the opposite of mobile? Also completely unclear. Like, is there a term that someone knows? I've been searching for one. Opposite of mobile?
You used desktop earlier.
Yeah, so desktop, like, does that include laptops? All right, anyway, I rest my case. But I think we can define it as what it is not. I think it's clearly not this thing. So a lot of web developers are still thinking about that as the platform that they're targeting. And this has got to change. That's definitely clear. Because today, the web is viewed by this sort of spectrum of devices. So pretty much any consumer electronic thing you get, like even a Kindle will have a web browser. And I mean like the old school ones with the e-ink displays. So, this trend is only going to increase, right? Like we've got all sorts of crazy stuff coming down the line. And nobody can even predict like what the next thing after touch will be. So here's an example of some interface that hopefully HTML will be around for, gesture-based things. And I'll just show you a quick video of the kind of stuff that I'm particularly excited about. So here's a quick demo video from a HCI research conference. This is just like to kind of get people thinking. It's not really relevant to probably the things that you're building today, but I'm sure it will be one day. So these kinds of interfaces are still like very much in the academia world, but like they're clearly coming at some point, and maybe not this one, and maybe not some other one. But anyway, just like be excited by this stuff. I hope you are. I am. So even though there's this huge diversity of devices, I think we can still generalize and point out a couple things that are definitely difficult with mobile. So if you thought that supporting IE 7 or 8 was hard, I think you're in for an interesting experience. So although we have pretty good mobile browser, like the modern platforms support, mostly it's WebKit based. So on the surface it seems, okay, well it's all WebKit, so that's fine, we'll just write for WebKit. But in practice, it's a whole bunch of different WebKit versions. It's a whole bunch of device-specific things that people add on top of WebKit. So this story is quite difficult. Slow CPUs. So this is also unlikely to change drastically in the near future. Like we've got basically order of magnitude slower machines in your hand than on your desktop. So you need to figure out how to best leverage that. And also alternative input. So right now it's touch. In the future it might be something else. And these are questions to solve. And I'm not just throwing these things out. I'm actually this is what I want to talk about today. So we'll hopefully cover all this. And debugging is terrible. But you probably, well, I'll save it if you don't know what I'm going to talk about. OK, so starting with many devices and platforms, the question you're probably asking is like, you need to decide which ones to support. I'll talk about various trade-offs here. But before I do that, let's talk about some design questions. So you're designing for some users. Hopefully you have that user in mind, at least to some extent. Like you might be thinking, what are they using? Like, is it a desktop? Is it a phone? So maybe your naive approach is, hey, you just like build one version of your site for all the devices. Just serve it. So this is great, right? You just write it once, you're done. But basically, you've completely neglected the differences in usage of this site. So someone that's on a mobile device and someone that's on a tablet is probably using their electronics very differently from someone on desktop. So even actually within the form factors, or sorry, within between desktops and tablets and phones, a lot of people on Android and iOS have been creating customized versions with drastically different versions of their UI. So Flipboard is an example of this. They have a completely custom phone version that they recently launched with the intent of supporting single hand use, whereas their tablet version is optimized for two hands. And it's a very different experience just because of the way people use their app. This is another example, show you it's similar to Flipboard. I think it's more for videos. I actually haven't used this, so. But the bottom line is, yeah, if you have one version, your UX will suck. So the alternative extreme is just make a version for every device you want to support. So you'd make an iOS version for iPad, for iPod Touch. You make an Android Touch or Android tablet version, an Android phone version, et cetera, and serve the custom versions. So the problem with that is it's going to suck for you. You'll create good experiences, but as a developer, you're going to end up doing the same thing over and over. So I just mentioned Android and iOS. There's some complications here with making a single version for both platforms. But let me dive into platform specifics first. So platform specific, basically each platform like iOS provides a human interface guideline. And the point of this is it's a set of standard widgets that define the look and feel of your OS, right? And the framework that iOS provides, Cocoa, it makes it really, really easy for you to basically, the quote is, fall into a pit of success. So you're doing the basic things, and then you end up with a UI that looks kind of it looks like it fits on the platform, right? So this is the intent of native platforms. Some people take the approach that, hey, we can just use web technologies to emulate platform, native UX. The problem is you've basically screwed yourself over entirely, right? The whole two benefits of using the native UX are that it was easy and that it looks consistent in the platform. So now you've done something that's very difficult and it looks like crap on any other platform except for the one that you just developed for. So I don't mean to insult the work of this developer Chi. I think he did a very deep case study about implementing an iOS look-alike and feel-alike version on the web. I'll just open it up and show you if it loads. anyway, it basically was a feat of design and engineering to replicate all of these iOS metaphors from things like recreating the CSS gradient perfectly to like setting to making it feel right. So to like setting the screen size correctly. He also did this thing where he dove really deep into buttons. So the way buttons work on iOS, there's a touch target and then there's a release target, and they're actually different. So you can like tap on the button but then release outside of the button. Anyway, you're in for a world of pain if you take this approach, and then you have to do it again for every other platform. So I'm going to posit that this is not the web way, and that we can embrace what's good about the web and not do these things. Although it's a great exercise and good on Chi for persevering. So there's a trade-off here that I'm trying to allude to, which is that the more versions you create, the better each version will be, but the more effort it will require from you. So there's some middle ground that we need to find. And I also have this slide. So one other thing about platforms is they differ, and they differ in sort of subtle ways that it's very difficult to say, well, basically screw this guideline over. So the guideline here is, you can see there's a difference between Android on the left and iOS on the right. The main difference here is you've got your menu bars positioned in different places. And this isn't an accident, it's actually by the guideline of the platforms. So iOS says, hey, we've got a physical button on the bottom, so you won't really be likely to accidentally push one of these buttons that are on the bottom because, hey, it's a physical button, so you're going to feel it. There's tactile feedback. Whereas on Android, you've got soft buttons, so we want to place the menu as far as possible from those soft buttons so that if you accidentally hit back, or if you're going for friends, but you accidentally hit the back button, that's like a pretty drastic mistake to make. So there are differences, and there is a compromise to be made here. But the differences between device classes, like phones and versus tablets, are smaller than differences between platforms. So I guess what I'm recommending, well, I'll get to what I'm recommending. It's basically a compromise. So if we create desktop versions, tablet versions, and phone versions, I think we'll be somewhat further along than just creating versions for everything or creating only one version. But we need to distinguish between them somehow, right? So one thing that's been really great for the community, I think, lately, is media queries. So how many of you have actually used these in your own sites in production? Cool. So you probably know what they do, but the basic idea is here you can say, basically you specify conditions that evaluate in CSS. So you're saying here that if you're dealing with a screen device and the width is it's smaller than this value, then specify this style. And here we're saying if it's between this threshold and this threshold, use this style, which is being truncated here. And similarly here, you'll notice I'm using these variables. Actually, this is a really sweet feature that just got added to SCSS. It's in the pre-release of SCSS. You can now use variables in your media queries, which is great. And just in case you haven't seen this stuff in action, I should unfull screen. The point of this stuff is, at least on the desktop, it's a little bit contrived, I guess. But on mobile, if you're getting, thanks, Peter. If you're getting served a content on a smaller screen, you'll get this version. But if it's a larger screen, you'll get a different version. This isn't very dramatic, but let me load up something where it's clearer. So here, think Vitamin has this layout, right? But if you were to see it on a tablet, let's pretend this was the size of a tablet, you'd get this. And if I was able to resize this smaller, you would see that it's a completely different layout. So that's the basic idea of media queries. And you can do more advanced things as well, like detect orientation. So you can see if you're in portrait mode or in landscape mode and change the CSS again. So yeah, I recently discovered that you can do this. This used to be completely non-platform friendly. Basically, it was available on iOS as of like 4.3 maybe, if I'm not mistaken. And Android didn't support this at all. So now Chrome for Android.
Chrome's not the default browser for Android, right?
Chrome is not currently the default browser. You can get it from Market if you have an ice cream sandwich device. Right, so there's some limitations though, right? If we're just customizing the CSS of our site, we're dealing with the same DOM for every single version. So that means the phone has the same version of the DOM, the tablet has the same version, and the layouts may actually be drastically different. So what you end up with is a lot of CSS hacks to like position things in the right place, where if you were able to customize the DOM, you would have to do this way less. There's also no way to load like additional scripts or functionality if you want to have like form factor or device class specific things. But I'll go more into that in a second. And also the other thing is if you're serving the same version, basically if you want to optimize your network transport somehow, say you know like certain devices are really good at this kind of thing, like you want to gzip in some cases but not gzip, you don't have that flexibility here either. Right, so you can do media queries in JavaScript. There's a thing called match media, and this lets you basically run any media query in JavaScript and see if it matches the current state of your browser. So here, sorry, we're running this media query here, and this will evaluate the true if it matches. That's it. So we can detect essentially between these device types if we want to take this approach by just having the logic like this. Really, really straightforward. Just like, is it a touch device? If it is, then we see, is it small? Then we serve the phone version. If it's big, we serve the tablet version. If it's not a touch device, we fall back to desktop. But the question is, where do we draw the line? And a lot of the time, I think people that are in this space are developing entirely for iOS. This is not good for the web. iOS has historically been a fantastic browser. And I think right now we've really picked it up at Google, and we're actually stepping up with Chrome for Android. So I'm very hopeful that we'll be able to create a competitive offering. So I think that, assuming that everything is an iPhone or an iPad is not the right approach. So we need to consider other devices. So here is a little graphic. I hope you can see it. But basically, it's a list of a bunch of random devices, including iOS devices, with their respective screen resolutions. So here is an iPhone. There's a Galaxy Nexus, a Galaxy Note, a bunch of tablets here. And you can see it's a pretty wide spectrum. It's a pretty wide gamut of devices. So some of them are kind of also they straddle between the two form factors, like the Galaxy Note. I don't know if you've seen it. It's like a 5-inch device. So I guess some people just want a big screen, but other people don't want to hold a giant thing to their ear. So it's a trade-off. One thing to note here is CSS pixels here are actually not screen pixels. So for example, the iPhone, when iPhone 4 was released, there was a Retina display in it. And what that basically means is it's double density. So instead of 320 by 480, the resolution is actually 640 by 960. But CSS still pretends that it's 320 by 480, just to not break the web. So everyone else has taken the same approach. And now a lot of Android devices are double density too, but it's just not branded as Retina, but it's still double density. For example, Galaxy Nexus. Its native resolution is actually 720 by 1280. So anyway, it's good to know that, even though it doesn't really affect you in this particular case. It'll probably shoot you in the foot at some point. So the other complication is that all these devices are also capable of landscape. So now we have to think about not just the width, but also basically the max of the two dimensions. And what you get, if you look at that, is you get this like bunch of squares. And we can, right now, with today's landscape, roughly draw the line at about 640, 650 pixels and say, okay, if it's bigger than this, it's a tablet. If it's smaller, it's a phone. So this is the kind of heuristic that we're recommending right now. The Chrome team is recommending for doing client-side detection. So basically, to implement the code that I showed in the very beginning, well, a couple slides back, we can check touch support by just saying, okay, we'll defer to Modernizer. Paul and Farouk have already done the heavy lifting of trying to detect touch support in a cross-browser way. So Modernizer, if you're not familiar, it does this thing where it checks featured support on your current browser. It doesn't always work, and there's been some false positives before. Like sometimes an unstable version of a browser says it supports touch, but actually doesn't. But these are outliers. Generally, this is pretty good. And with small, we just use a media query here at 650. So that's cool, but the threshold will change. New devices will be added. You know, this is a work in progress. Anyway, so the other approach is server-side detection. So this in monospace font is a user agent string. Does someone know offhand like what device this belongs to? This is my favorite archaic part of the web. It's just so incredibly messed up how the UA strings have been just constantly added to over the years, over the decades. But anyway, does anyone have like a good idea?
Nexus 1.
Maybe. Yeah, I mean, it's a good guess. I mean, the thing that kills me is that there's like so many mixed messages here, right? If you look at it from like a non-web veteran perspective, it's like, okay, well, it's Mozilla, so it's probably Firefox. Android, okay, maybe it's Android browser. But then we have WebKit. It's like Apple WebKit, really? And mobile Safari, so, and Gecko here. So it's just like an amazingly arcane piece of, arcane artifact here. But anyway, it's hard for me to know what this is. But luckily there's people that have like spent a lot of time solving this problem. And there's device databases out there that kind of help you along the way. One is Device Atlas, another is Wurfel. Wurfel harkens back from like the days of, you know, feature phones and WML, that kind of thing. So it's really legacy stuff. For example, Wurfel's basically it's a database based on an XML file, and the XML file is 20 megs. It's just like 20 megs of XML. So it's like, I don't know. I did way too much XML stuff back in the day, and it's like a nightmare. 20 megs of XML. But anyway, I should stop knocking it. I guess the other limitation, though, is it doesn't explicitly say what device for class you're dealing with. Like, you get a bunch of information, like, does it support MP3? Does it support OGG Vorbis? And like the screen sizes. But it's just so much information that I think it's intimidating for developers to get started with this. And we definitely need a better solution, which I can't really, well, propose. Well, we'll see what we can do. There are lighter solutions, though, that aren't as robust. So detectmobilebrowsers.com is an example. It's basically, well, I can show you. No, I won't show you. But the point is, it's a regular expression that's implemented in a bunch of different languages. And it basically, it says, okay, is this a mobile browser or not a mobile browser? And it doesn't distinguish between tablets either. Actually, it's kind of funny. I think I'll show you. Okay, so there's this section here, and if you care about tablets, so they're not detected by design, right? But to add support, you could just tweak your regex. It's fine. Just like go in your code and tweak it. So this is the current answer, and it's like really unsatisfactory, I think. So I'm hoping that we can get a better one soon. Right. Or if you're very particular and you know exactly what you want, you can just implement your own. The point is, this approach is kind of hacky, it's ugly, there's problems with user agents, so I'm not a big fan. But let's talk about trade-offs. So with the client, basically there's three options, right? You can load all the content for all devices. So what I'm saying here is you load the images for your tablet version on your phone. Just don't distinguish at all. And then have some JavaScript that decides which things to actually use. So this is problematic because you download all the stuff, so you're wasting bandwidth, that's throughput, and you're also keeping a bunch of things in memory that you don't need, really. You could lazy load extra content with like dynamic script loading, dynamic CSS loading. Again, this has latency overheads because now you're requesting every single asset with an XHR or something like this. So again, not great. Or you could redirect to a version. So you could say, okay, well, I'm going to have up front a detector thing that says, is it a tablet, a phone, or a desktop? And then you redirect to some URL. And at that point, you've got a whole new reload. And like, given how bad mobile networks are right now, that might actually be prohibitive. But anyway, I haven't done the math on this stuff. I haven't done any analysis. So I'm just saying, like, these are the considerations. Whereas on the server, all you do is you have some regex that runs, and then you just serve the right version, and you serve exactly the right content, exactly the things you want to give to every device form factor. So I think it's pretty clear that from a performance perspective, the server-based ugly UA parsing is actually the thing to do. And I mean, a lot of Google properties are actually doing this. Mobile Gmail, for example, they use a variant of Wurfel in order to detect on the server, and they serve, they basically serve the customized version. And they go very granular, so they serve very different versions depending on your device for feature phones, etc. But I'm not proposing you do this because it's just so much overhead. But your client might care in particular about some old version of some browser. Yeah, this slide says what I just said, except much more eloquently. Okay, so the one thing to consider still, though, is that even once you're in a form factor, device class, you want to scale well within it, right? So devices aren't, like all tablets are not the same. They come in different aspect ratios, different resolutions. So you want to use like %-based layouts, Flexbox Model, maybe not. We'll talk more about that. So don't assume that you're dealing with a 1024 by 768 iPad. Right. Oh, yeah. So right now it sounds like I'm saying, okay, cool. We don't have to build 9 versions, but we can build 3 versions. And you're like, okay, that sucks. I don't want to build 3 versions. I want to build 1 version. Yeah?
Yes.
Cool. So the answer to that, I think, is basically you're doing it wrong if you're writing 3 versions at this point. So hopefully you've got some sort of reasonable abstraction in your code. You've separated your models from your views. You're using Backbone or Ember or some other hot JavaScript framework. There's been a nice renaissance of this stuff lately. So there's like at least 4 to choose from, but I think most people are using Backbone. So whatever, if you like Backbone, go for it. And the whole point of that is you separate your presentation from the model. So you have like a separate layer for views, for handling input and for rendering output. So what you can do in this scenario where you have an MVC is you've got your regular MVC down here, right? That looks familiar probably if you've dealt with MVC. If you've not, yeah, there's a lot of good talks out there. So you should check them out, and I definitely recommend it. But all you do is, with your detection, you can simply swap out these views. And you say, okay, well, I'll make a phone view that handles the input and draws all my layouts. Then I'll make a tablet view. And they'll all work with the same model and the same controller. So maybe you'll have like a more complex setup where you have multiple controllers. And that way, then you can decide like which features do I need on each platform. So anyway, here's an example roughly of how this might look in, say, Ember.js. So here you might have like common code. So you have app.js, and I'm simplifying here. You would probably want to separate models from controllers, et cetera, et cetera. But here's the main logic of your application, right? Then you have some detector and maybe a loader somewhere in there. And then you have like your views that include maybe a template. Ember uses handlebars. A view, this might implement a whole bunch of different views, and some CSS styles. And you can load all these things dynamically. Like the code for it isn't even that scary. Pretty much I've included everything except for the template, which is actually kind of scary in the case of handlebars. But you can easily lazy load all this stuff. And it works pretty well. So this is the client-side approach that I think is interesting, and I've tried this for a couple apps, and it seems to work okay. So that is that. But again, just to recap, most people are using server-based detection still, and I'm not sure if that will actually change. Okay, that's sucky thing number one. That I hope is less sucky now, maybe. So sucky thing number two is that CPUs are really slow, right? So we have like 1/10 of the speed, say, in your ARM, in your Android phone compared to the dual quad-core thing in your laptop, for example. But you still want 60 frames per second everywhere, right? Because that's you want a good experience, especially on mobile. Actually, the way native apps are shaping up. If web is to remain competitive, we need to have good experiences, and we need to, like, from a UX perspective, compete. So how do we do that? Basically, try not to do anything on your CPU. Try to offload to GPU rendering or like call native APIs. Not like PhoneGap native APIs, but like stuff your browser handles for you. And I hope you guys recognize this thing. Anyone recognize this thing? Anyway, sorry. It's an Animaniacs reference. Anyway, we'll get there. Okay, so one thing that is really expensive, as it turns out, is scrolling. So it's just been, I don't know, I was so surprised that scrolling is hard, but it actually really is. Working with Eng team, it's non-trivial. So the way you do this, and I guess by scrolling what I mean is you want to scroll separate parts of your page, not just like scroll the whole thing, but like if you want a div that scrolls independently from another div. So you do this by setting the CSS property overflow to scroll, or auto, which will scroll if your content is too large for that div, or whatever element. And there's also a way to enable native-based scrolling. So as of iOS 5, you can do it with WebKit Overflow Scrolling Touch, and this will let you just flick and do the kinds of gestures that you expect if you're on an iOS device, and it just works. I mean, there's some caveats. It doesn't work in all cases. There's known issues, etc. And on Android, ICS and up, both the Android browser and Chrome for Android support native scrolling by default. The behavior is slightly different. You don't have like the bounce back effect. You don't have, yeah, that's the main thing, I think. There's like also inertial differences, but this is, it's much better than just the jarring feeling of, okay, I'm in a browser, so when I scroll, it behaves completely different, and there's no like momentum. It feels like, you know, a second-class citizen thing. So this is the approach that you should be taking. Forcing GPU. This is really tricky, actually. There's no explicit way to do this, unfortunately. I really wish there was some more explicit API for just saying, okay, this part, I want it on the GPU. But there isn't. So your alternatives are either you use Canvas, which is hardware accelerated by default. I don't even think you can get it into software mode. But this is both on iOS and on Ice Cream Sandwich and up. Hardware accelerated Canvas. So that's good. We actually perform very well on the benchmarks that we've run against. I'll show you some of that. And then there's CSS3 Transforms with a z-coordinate. This is really, like, it's really ridiculous the way this works, but unfortunately, the way you get your like div or whatever element into the GPU is you say transform it, and you pass in the identity transform, which is, you know, in this, it can be a translate z or it can be a rotate or something. But at this point, it's the browser knows that you're trying to do GPU-y stuff. And I'll show demos of this in a second. I want to batch it together because, you know, we'll have camera pane and stuff. The other thing is layouts. So there's a lot of things that the browser supports natively that you don't need to create JavaScript for anymore. Fixed headers and footers is a big thing. So this used to be something that frameworks like jQuery Mobile would do. And what they would do is they would say, okay, well, whenever you scroll, we're just going to reposition your header and your footer. We'll run some JavaScript and like put the header at 0 and put the footer at 0. But now with position fixed, you can just do that, and the browser handles it, and there's no JavaScript overhead for that. So that's great. And it's available, I think, as of iOS 5, and also in Chrome for Android and the Android browser. There's also the Flexbox model, which sets out to be like a really nice, super easy to use layout model for app-like layouts, where basically you have not just content flowing, but you have like an app with, you know, maybe multiple columns, some of the columns scroll, etc. Unfortunately, the spec right now is in pretty bad shape. Well, it's in good shape now, but the fact that it recently got updated with a completely uncompatible, like backwards incompatible version is kind of setting us back a little bit. So we had display box, which had some like subtle performance problems just by design. And it's been updated now, just like late last year with a V2 of it, and it's now implemented in Chrome. It's not yet available in Chrome for Android, but it hopefully will be soon. So once it is, I think I'll be more comfortable saying, hey, you should just use this. But for the time being, you're kind of stuck without it. Okay, so let me just show you a quick demo of the Flexbox model just to explain why it's good, and then I'll show some demos on the device. Okay, so this is the Flexbox model. So you can see that you've got a standard kind of header and a 3-column layout. The cool thing here is you can see instead of doing crazy float hacks and like, you know, position or maybe positioning manually, all this does is it says, hey, I'm in a box, or sorry, I'm in a Flexbox layout. So I'm going to say, this will be the second element in this layout. And by the way, this layout flows horizontally. So here I'm saying, okay, the main section is Flexbox, and it lays out horizontally. And then the children here, we can say, this is the index of this child in this flow. So basically, it's completely semantic, and there's no like weird things that you need to do to get this kind of layout working right. And now is the fun part, where I attempt to show you things with this great camera. So I talked about CSS Transforms. So I've been working on a small little demo of that, and I'll just show you on iOS just for fun. But boom. Okay, that's pretty glary. Let's try this. Okay, so this is just a content flow. Can you guys see this at all? Yes. All right, cool. So basically, the effect that I was going for is like a smooth transition, almost like a flipboard-like effect. And what this is using is it's using CSS 3D transforms, responding to touch events, and it's got a perspective transform in it too. So kind of you can really see the fluidity of the kind of thing that you can achieve using this approach. And this is all, pretty much it's all being done in the GPU behind the scenes because, I'm using the Transform Z hacks. So kind of nice, feels pretty good. So that's one of the things. And another thing is, right, canvas performance. So I'll just show you side by side. A test suite. This is actually written by the guys in the IE team. And this is their infamous speed reading benchmark, I think. And what it does is basically it scrolls a bunch of text as fast as it can. And this is getting like 35 frames per second, which is pretty good. And Chrome does well as well. So both of these modern browsers are hardware accelerated. So let me just show you. Right, so that was just network latency, basically. T-Mobile, So yeah, pretty good. Getting 50 frames on the Android and 35 on iOS. So we're getting there, and this is a huge priority for the team, just performance on mobile devices. So we're going to push this envelope even further. All right, so let's talk about input. Basically, right now, phones and tablets have almost universally switched to touch input. This is very different from the previous mouse and keyboard. And let's just quickly step through why. So here's like an old school keyboard and mouse, right? You'll notice that there's two distinct devices, and they have like completely separate purposes, right? So with touch, you only have basically one input method, and all you know is when a touch begins, when it moves, and when it is released. Whereas, so for example, let's take scrolling, for example. Scrolling with the mouse is either you're doing it with your mouse wheel, which is very easy to detect, or you're dragging a scroll bar. With touch, clicking and scrolling are very, it's a non-trivial thing to distinguish even something so basic, right? Because it's basically from the recognizer's perspective, your finger is coming down and then it's doing some stuff and then it's coming up. So this is like a completely different model to program for. And in early phones, I guess we had like more of a keyboard and mouse metaphor, where the BlackBerry would have a physical keyboard and then it would have like a little nipple that you would move around. So as we move to touch, though, it's really quite different. And basically with touch, it's all about gestures and just things that completely didn't exist. So let me just show you something that, again, I'm into. Here's a cool demo of an iPad app. And this is just multiplayer Pong, if it loads. I mean, it's still multiplayer Pong. Just might not load. All right, well, we'll just let that. Okay, cool. It's like totally not worth this wait time, though. Okay, so you have like a multi-touch display and 4 people playing on one touch device. This is cool. You couldn't do this at all before. So I'm hoping we can bring more of these kinds of experiences to the web, because it's frankly completely awesome. And there's other similar things, but I won't show you them in the interest of time. But I would like to say that it's not just about being completely awesome. It's also about being like just the way UI is evolving. It's very much more gestural these days, and we need to, on the web, keep that in mind. So one thing we don't want to do is pretend that touch events are just mouse events, because they're not. It's completely different. This is a bad idea. Like, okay, it's not a mouse because there are many actual differences. Like, there's no hover state. When you move your finger around in the air, there's no way that your finger is being tracked, right? So if you're relying on hover state, you're doing it wrong. There's multiple fingers, right? You don't have a single pointer. It's many pointers. And also some things that aren't currently implemented on the web but are implemented in a lot of other environments are shape. So it's not just, sorry, I don't know why there's a Z coordinate, but it's not just XY coordinates. It's also the shape of your touch. Like, are you pressing hard? Is it just a small tap? These are different things. And in the future, we'll have haptic feedback and pressure, potentially. So on the web, there's a spec recently, actually, surprisingly recently. This was standardized about a year or so ago. Before, it just used to be some de facto standard. But essentially, there's 3 main events: touch start, touch move, and touch end. So when you touch down, then the event fires. I mean, it's pretty straightforward. And there's an event payload. Touches is the array of all the touches on the screen. Target touches just includes the ones on the element that you've bound to. And change touches is useful for, like, say you've got a touch end, and you want to know which finger was released. You have multiple fingers on the screen at the same time. It'll include that information. The thing that's really lacking here is there's no gesture API. There's no gesture API that is open and available across platforms. Apple has one, but it's not being standardized, I think, for some patent reasons or something. But basically, there's no standard way to do this. And I'll talk more about that in a sec. So one actually compelling reason for you to use touch is clicks are delayed on every mobile browser. So if you're relying on click, the event, that's going to have 300 millisecond latency right there. And people can see that immediately. The reason for this delay is basically the browser needs to decide, is there a click happening, or are they trying to scroll, or is it a pinch zoom? And these events aren't actually revealed to you as a developer, but it's internal to the browser. So the workaround is to use touchend instead. And here's where we go into like this territory where it's kind of a big deal to implement. So it's there's a separate study here, or a separate link to an article about how to do this. But the basic idea is you use touchend, and maybe your touchend target will be slightly bigger because the button and the release target may not be the same. But this article goes into that detail. Okay, active state. So this is something that triggers when your mouse is down on desktop. So you've clicked on a link, but you haven't released it yet. On touch, this is not by default available. So this kind of sucks. And there's a workaround which I really dislike because it just seems like a hack. But I've tested it across several browsers, and it seems to work. And here's the code to do that. So with this code, basically, you'll actually get the CSS selector to fire when your finger is down on the link. I don't like it, but whatever. Also, you might have a single page UI, or you might be doing some very complex gesture stuff. And it may be useful to disable zooming and scrolling, because by default, the browser just takes these gestures and does what it wants to do with it. So it'll zoom the page if you do a zoom gesture. So the way to do that is you set your viewport to no scale, and you can just prevent default on the touch move. That'll basically prevent any mutation from the browser's end. Okay, finally, sorry, this is pretty technical, but essentially with multitouch, if you have like many fingers on the screen at the same time, you can imagine there's a lot of events that are firing, and they will fire very quickly. They'll start to fire at faster than 60 hertz. And there's no reason for you to be rendering faster than 60 hertz because there's no perceptible way that like the user won't see it. So the solution is to decouple the touch input recognition from the rendering. So here's a really simple way to do that. Basically, the canvas here is listening for touch moves. Every time there's a touch move, it will save the touch array, and then there's a separate timer to render. And here I'm using set interval, which is not what I would be recommending for desktops. But right now, request animation frame is only available on Chrome for Android of all mobile browsers, so I can't really recommend this technique in earnest. But hopefully soon everyone will be implementing request animation frame, and that should be basically what that is it's a way to say run this code if you have cycles to if you the browser have cycles to render things, and it's the recommended way to get good animations going. So check it out. There's good resources about this, but for now it's not really a mobile thing. Okay, so now that we've gone over all this gory detail stuff, I'll tell you that some of this is solved for you. There's frameworks like Sencha. You probably don't want to, well, you might want to use Sencha, but then you're using all of Sencha, which is generally how it works. There's also gesture recognizers that are standalone, like hammer.js. And if you don't get the name, it's kind of cool. It's actually about hammer time. And you can't touch this, but anyway, so you can also simulate touch events in the desktop. And bear with me, this is like a total plug for my little pet project. But basically, let me show you a quick demo. So one of the things with multi-touch, if you're doing complex gestures, it's really hard to debug on a mobile device. So one possible solution is use MagicTouch, which basically lets you simulate events from your Mac, from the trackpad on your Mac, and bring them directly into the browser. So I'll show you a quick demo. So this requires installing an NPAPI plugin, dropping in scripts, but I figure it makes for a cool demo, so I'll show you anyway. And then running this Tongseng thing. So here's a tracker. And all this does is it shows the fingers that are on the screen. And I'm running the Tongseng application, so all I'm doing here is I'm touching the trackpad. So if you want to do some weird gesture thing, you can just use this. And all it's doing is it's emitting touch events for in your desktop browser. So this I find quite useful, and some people at Facebook are now using this, so that's cool. But yeah, right, there's a really silly thing. This is like just a small sample of, this game doesn't even make sense, but it's like Fruit Ninja, but with browsers. I'm not sure. Anyway, it's a stretch. And you're supposed to not get the blink tag for some reason. I wrote it, so I should probably know what's up. But anyway, you can see it's multi-touchy, so that's cool. I'm just waiting for the blink tag to come up so that I can accidentally get it. And it's, yeah, all the errors are for oh, okay, so I lost it. Anyway, sorry. Right. But I would actually like to show you some demos on a device. So let me just quickly switch over. So the first demo is one written by a guy called Seb Lee. And it is a multi-touch game controller. Uh-oh. Okay. Test. Okay, so you can see that basically there's a little asteroids-y thing, and as soon as I put my finger on, it creates like a virtual trackpad, or a virtual touchpad. And then the other finger acts as a shooting thing, gun. So I feel like the camera isn't really showing the latency, but it's pretty good here. Like it's really responsive, and it feels pretty much native at this point. This is Chrome for Android, and it works very well in iOS as well. So examples like this are things you can't do without multi-touch. And it's clear to me that this is a great thing for the web, I think, and we should be embracing it and doing more cool stuff with it. Oh, and right, as I mentioned, Sencha also has gesture recognizer, similar to the one that Hammer.js provides. Maybe I'll save that just in the interest of time. But basically, instead of figuring out where the taps were and recreating your own touch stack, etc., you can just use Hammer.js and be done with it. Right. So mobile debugging. The story here has been pretty bad historically. So recently, well, there's a debug console in iOS. Basically, you can turn on debugging and you'll get all your console logs outputted on the top. This isn't great. If you're debugging through console logs, you're probably doing it wrong. So there's actual remote debugging in RIM's playbook, but unfortunately, I don't know anyone that has a playbook. But I wish I did. It's a great device. There's also Winery or Wiener, depending on how you like to pronounce things. And it's a cross-platform debugging-like solution. It doesn't actually let you debug, but you can like inspect elements and look at network stats. It's pretty basic. But debugging used to suck. It's actually like way better now with Chrome for Android. Yeah. So the question was, are there plans to support Chrome on previous versions of Android? I guess like Gingerbread or Honeycomb. And there's no plans at the moment. The current platform offers some good hardware accelerated support, just like low-level stuff, whereas previous versions of Android don't really offer that same quality of hardware acceleration that we'd like to see in the browser. So unfortunately, not at the moment. Other questions? All right, cool. Sorry, that's it. If you want to like ask about other stuff, like that video question, just find me later. I'll stick around for a little bit. Thanks, guys.